N6HWW here. Today we're going to talk about the American Legion Radio Shack, the Kenwood TM V71A that's inside that shack, and some first principles of radio communication. So I got into the room. Now what? Well, there's a series of radios that are installed and in the room. And so we want to go for the middle one. That's the Kenwood TM B71A. So the front of this radio, it's got some buttons on it, and it's got a display in the center. What you want to do is you want to power up the radio. You want to push the call button, which will then configure the radio in a specific way. Then you can be able to communicate over the frequencies. Power button, call button, you're ready to go. Let's take a little bit more in-depth look at this device. The Kenwood TM V71A is a dual band VHF UHF radio. Dual band means that it has two transmitters and receivers in one package. You can see how they're configured, each one of the bands, on the front of the device. We have band A and we have band B. Bands are controlled by the knobs on the right side of the unit. Also, between those, you can see a legend that tells you how these knobs work. These are multifunction knobs. They have a crown, and then they have a ring, and they also support pushing. If we look at them, we can be able to see the volume is the interior knob, the squelch is the ring, and when you push it, that selects which of the bands is in the control position. We can see here that the band A is in control as identified by the word control up in the upper left-hand side of the display. What this means is that when you key the mic, it's going to be using the information that's provided to you on that display. There's another big knob on here. It's called the tuning control knob. Now, the tuning control knob is also a multifunction knob. You can rotate it, and depending upon how you're configured, it will select the operating frequency, the tone frequency, a memory channel, or change the scan direction. It also has a press function, and when you press it, you can toggle the display between megahertz and memory channel name. And if you press F, then the control tuning knob, you enter into the menu mode. Now, what happens if you want to tune your own radio frequency into this? Well, you do that through the Vfo knob, and Vfo stands for variable frequency operation. When you turn this knob, it controls the frequency of the current band. As you rotate this knob left and right, it changes the frequencies that are shown on the current band, allowing you to manually tune to a given frequency. The other button right below that is memory channel mode button. Puts the radio into the memory channel mode. This means that when you turn the tuning control, you are actually going through a memory selection. There are 1,000 memories in this that have all the information necessary to be able to communicate over a particular frequency. So now that we know how to be able to get to the radio, how to be able to go to a default configuration where we can be able to communicate, or to be able to manually enter in a frequency, or to be able to go to a stored frequency, let's talk about first principles of radios in general. Radios involve transmitters and receivers. The first thing you have to do if you want to communicate over a radio is that you have to agree on the frequency. This establishes a link between radios. You spend most of your time listening. And so you would tune to this frequency and listen to it just like you would an FM or an AM radio. The unique thing about ham is that you can also be able to talk. So when you push the transmitter, you can be able to transmit information using that frequency, and anybody who's tuned to that frequency will hear it. One of the things is that there is a protocol associated with the use of a frequency so that only one person is using the frequency at once, and this switches back and forth. But this is a logical construct. In other words, there's nothing stopping you from going and using the same frequency as someone else and causing a problem. This is called simplex communication. One at a time. Radio waves don't go through hills, and they're impeded when they go through buildings or trees. Radio configuration is pretty simple. Tune to a shared frequency, listen, and then transmit. However, if two people transmit at the same time, you get interference, and it's a toss-up as to who will win that battle. That's not a really super good way to be able to do it. For instance, on your cell phone, you can be able to talk and listen at the same time. That's kind of normal for a telephone. That requires two frequencies. Again, we have to have some kind of agreement on these frequencies, and we have to agree on the direction. In other words, I have to be able to say, I'm always going to be transmitting on one frequency, and the other person is always going to be transmitting on another frequency, and we can listen on the opposite frequency. In this graphic here, the person on the left is talking out 146.020, and the person on the right is talking out 146.520. So in this configuration, they can be able to communicate simultaneously. This is called duplex communication. You have two frequencies, you agree on the direction, and now you have simultaneous communication. It is still subject to interference. So you have to have this logical agreement on what's the process that you would use so that you avoid having two people talk on the frequency at the same time. The world isn't flat. So what does that mean? Well, there's the actual physics of our world. First of all, there's a limited number of frequencies that are available. That's called the spectrum, and they're divided up. We want to reduce the amount of interference because we use the spectrum for all kinds of things like our garage door openers or our cell phones or our FM phones. So we develop what are called band plans, and that just breaks up these frequencies into an agreed on way. We want to, if we're a transmitter, use the lowest possible power. This is to reduce the chance that you are going to be communicating with someone and having that communication lead over into someone else's environment. These have a locality-based part of their functionality. So VHF and UHF is basically line of sight. Now we can be able to leverage the topology. If we go up high, we can be able to probably reach more people because we can be able to see them. And we can also be able to use topology to be able to block radio waves from one area to another areas. For instance, if someone's in Bakersfield and the other person is in LA, because of the mountains in between them, it's very unlikely that that's going to bleed over. Now, you can be able to have these things in all kinds of different places. The topology has a big impact on it. So when you're looking at your deployment of radios, in our case, for emergency communication, you want to identify what are called repeaters. Repeaters use that duplex communication method that we talked about earlier. What a repeater does is it sits up in a higher location and it is visible by the people using it. The people using it all agree to listen on a specific channel and transmit on a different channel. So that means that you spend most of your time listening, and when someone calls and there is free time, you can be able to then key your mic. Your transmission goes up to the repeater, and it is then transferred over to a secondary frequency and transmitted out. That way, the other people who are listening on that frequency can be able to hear you. So you listen on one frequency and you transmit on another frequency. Well, that's it for today. This is N6HWW Clear.